Hi, welcome to the next assembly video for the Prusa i3. Now, if you've been following along with me, you should have an almost complete Prusa i3, just like I do here. And we just have a few more steps and this thing will be printing. We got to get the software configured and a couple more things. But let's go ahead and first plug in the USB. The round side will be pointing outwards and it plugs in right there. So let's see if I can hold the camera and do this at the same time. Okay. And then plug the other side into the computer. And before we get into the computer, let's go ahead and get the filament fed into the extruder. Now, earlier when we assembled this, we didn't make this real tight, so this is springy, so you can pull back the guidler, and the filament will go in right in the groove in the top of the guidler. You just want to make sure that it feeds in there okay. Sometimes you have to sort of bend it. Oops. Sort of get it kind of straight. There we go. And just push it all the way down until it stops. It should be about that long because it needs to go all the way down to the tip. So once you get it in there, then you can go ahead and tighten it up. And if you already have these tightened up, another way that you can do this is you can actually just start to feed the filament down and then manually move the large gear to get a grip on the filament and push it down that way too. Now I'm going to tighten these bolts until the end of the bolt starts touching the motor back here. And then just match the length of this one to this one. Okay, and then you can kind of test it. You can hold on to the filament and move the large gear up and then back down, and I can feel that it's moving the filament. Okay, and you can also go ahead and plug in the AC power cable for the power supply, and this thing will be ready to go. We can move to the software. All right, now when you when you first plug in the RepRap, it's going to it may automatically install the driver or it may not. So this is Windows 7 64-bit, so it might be a little bit different on a different version of Windows like Windows 8 or 8.1, but it should be fairly similar. And I expect that you'll know the differences if you're familiar with your operating system. But essentially in Windows 7 you click on Start and then you can just start typing Device Manager and then it shows up in the search results, and I can see Device Manager right here. And if you go into the Device Manager, you can open up Ports, and it should either show Arduino Mega 2560 or it might show an unknown device with an exclamation point, similar to this exclamation point here. And in my case, it automatically installed the driver, so I don't have to install it. But I'm going to go ahead and show you how to install the driver for this in case yours says unknown device. To do that, the easiest way is to go to the Northwest RepRap website and click on Support at the top of the page. And then scroll down to Software and click on the Software page link. Now I may change the way this is organized later now that we're going to start selling more models of printers. But for right now, I just put it all under Windows. There's two new links here from the Prusa i2 kit. There's the Arduino Mega driver only, and then there's the Slice 3R for i3. Now, the Arduino software here at the top also has the driver for the Arduino Mega 2560, but since the firmware is pre-installed on the ramps for the Prusa i3 kit that we sell at Northwest RepRap, you won't actually need to download this or the firmware, but you can if you want to. If you maybe want to make some changes to your firmware, you could definitely do that, or try a different firmware or something like that. But you know, if this is your first time with the RepRap, you might just want to stick with what we've provided to just try to help you along as much as possible until you get familiar with things, and then you can start to experiment with other firmwares or settings, things like that. So anyway, all we need for now then is the Arduino Mega driver only. So let's download that. Okay, and extract that. And I set up a downloads folder for the video here. So you might want to maybe make a directory on your desktop or something like that to keep your programs. But I'm going to delete the zip file now that I have it extracted, because I don't need that anymore. And then under the Arduino Mega directory here, there's two installers. There's a 64-bit installer and a 32-bit installer. And you would just run this, and there's an installation wizard, and you essentially just click next and go through the standard installation. And once it's complete, it will it'll automatically install the driver for your unknown device. It might take about a minute or so after it's done installing before you can go back into Device Manager and see that it switches from Arduino Mega from unknown device to Arduino Mega. And you also need to make note of the COM port location. In this case, it's COM 14. All right, so that's how you would install the driver under Windows 7. Okay. Next, let's get the rest of the software that we're going to need. So go ahead and go back to the Northwest RepRap website, and we're going to want to download the Slice 3R for i3. So click on that, and download that. And then we'll also need Pronterface. So let's download that. And let's download this 20mm cube so that we have something to print for our first test print. Okay. And I am done with the Arduino Mega driver, so I'm going to go ahead and delete that. And then I'm going to extract Pronterface. And then extract Slice 3R. And then I can delete the zip files. You can do that too if you'd like. Okay, and let's go ahead and open up both of these programs. Open up Pronterface, uncheck Always Ask. I'll go ahead and maximize that. And then go back and open up the Slice 3R program. And check Ask. Okay, and when you first open up the Slice 3R program, it's probably going to go through configuration wizard. This is the current latest version, which is 1.0.1, and it includes a wizard to help you with the a simple set of settings. So you're going to want to exit that and go into File and click on Preferences, and then change your mode from Simple to Expert. Okay, and that is what this mode is. This is what Expert mode looks like. And for the Prusa i3 kit from Northwest RepRap, we've actually included the config file right here that you can use. So to import this config file, what you would do is click on File, Load Config, and then browse to the place where you extracted the Slice3R program, and then click on the config.ini and click open. And this will import the configuration for the print settings, filament, and printer. And essentially I'll just go through some of those configurations real quick. That has a layer height of 0.3 millimeters. It has an infill of 70%. It has a general speed of about 60 millimeters per second, 120 travel speed, and 20 millimeters per second for bridges. Under filament settings, it has a diameter set to a diameter of 1.75 millimeters. The first layer for the hot end is 190 degrees Celsius for PLA, and then 190 Celsius for additional layers. 55 Celsius for the first layer in the bed, and 45 Celsius for each additional layer for the bed. These are good values to start out with. You're probably going to need to tweak these to get things just right. Essentially, you want to print with the lowest possible temperature that you can print. And that might end up being maybe closer to 185 C. But this is a good starting range to start out with. And then under cooling, we have the fan always on. And then under print settings, the bed size is 200 by 200 and the print center is 100 by 100. This should be pretty close to about right for your Prusa i3 kit, but you might want to tweak this to get it just right later on. But for right now, it should be just fine for getting things started. And then under extruder settings, the nozzle diameter is set to 0.5 millimeter. The retraction length is set to 1.5, and then extra length and restart is set to 0.5, and then the speed is set to 20 millimeters per second. So all of these settings should be great for your first round of print jobs, but you might want to go through here and play with a few settings and see kind of how they affect the parts that you print out. Let's go ahead and load the 20 millimeter cube as our first test part to print, first test thing. You can just drag and drop this into the Slice3R program. Okay, and then I'm going to go ahead and export the G-code now, so you'd click this button here. And I'm just going to save it to the downloads directory where I'm keeping everything else. And you can see down here by that green bar that popped up that it was working, and then now it says G-code file exported, which means it's done. Okay, so I'm going to go ahead and minimize that for now, and next we can go to the Pronterface application and click Connect. Now, when I first opened Pronterface, it checked all the COM ports and it automatically detected that the Arduino Mega, or the ramps, was at COM 14. Sometimes you might actually have to change this, but earlier in the device manager it showed what COM the Arduino was on, so it was able to auto-detect, and that's COM 14. And then you may also need to change your baud rate to 250,000, and that's the baud rate that's set in the firmware for the ramps that we send out with our kits. It could be different for yours. So go ahead and click Connect, and then if it successfully connects, what you'll see is in the log over here, it'll say printer is online, and all of these controls lit up. So you're now capable of operating the RepRap. Now there's quite a few things that you can do with these controls. You have the Y-axis here and here. This will bring the Y-axis forward by 0.1 millimeters, 1 millimeters, 10 millimeters, or 100 millimeters. You want to be careful on how far forward you bring the RepRap if you don't have an end stop switch ready to stop it. And then this will push the Y-axis backwards, 0.1, 1, 10, or 100 millimeters. And this is the X-axis, so this will move the X-axis to the right by 0.1, 1, 10, or 100, and move it to the left either 0.1, 1, 10, 100. And these buttons on the sides, on the corners, this will move the X-axis to its home position, essentially to the end stop switch, unless you have the firmware configured differently, but for the default firmware from Northwest RepRap, this would take it to the X-axis end stop switch. This would take it to its Y home, and this would take it to its Z home, and this button here would home all of the axes. And then this bar here is for the Z axis. So this side would move the Z axis 0.1 up, 1 or 10 up, and then down 0.1, 1 or 10. And if you're moving the z-axis down, it will move it'll stop as soon as the end stop switch is hit. And you want to make sure that we get the end stop switch for the z-axis in such a position that that the nozzle doesn't try to go farther down into the bed than where we want it to. So we're going to configure that. We're going to calibrate that in just a second here. But real quick, let me just show you what else you can do in this program. You can turn the hot end on right here. You can set the temperature by typing it in. And you can also turn the bed on and off, and you can set that temperature by typing it in here. If you click the check temp button, it'll check the temperatures of the thermistors. In this case, the hot end is at 24 Celsius and the bed is at 25 Celsius, or you can look down here, 24 and 25. The first number is the actual reading of the temperature here. And the second number is the temperature that you have it set to. Excuse me. Okay. And then the next thing here is that you can manually extrude. So you can set this, for example, to 5 millimeters and press extrude, and then that'll operate the extruder. You can also reverse the extruder too. And then a really important feature is you want to make sure that you monitor the printer. This is really helpful if you're going to be printing from USB. It'll help keep the session alive between Printerface and the printer. Okay, and then one last thing is you need to be able to load the G-code files that you want to print. And to do that, you click the Load File button here, browse to the G-code file. In this case, in my version of Windows, I have it set up so that it doesn't hide file extensions. So I can see here that this is a .g file. This might also be a .g code file for you. And if you can't see file extensions, you might need to look over here at the file type where it'll say G file or G code file. But this is the one that I want to load. So I click Open, and then it shows a preview of the object that I want to print. And we're not going to print this yet, but let's get the Z height where we need it to be before we can actually start printing anything. Okay, and to do that, I'm going to move the camera back and try to show the printer and this control panel simultaneously so you can see what I'm doing and how the printer responds to what I'm doing. Okay. All right, so I'm going to try to move the Z-axis down 1 millimeter. Oh, forgot to plug in the AC cable. I told you guys to do it, but I didn't do it myself. There we go. Let's try that again. So I'm going to move the Z-axis down 1 millimeter. Okay. So it looks like the Z-axis is operating just fine. Now one thing I'm not sure about actually though is whether or not these two sides are level, because I never checked that earlier. So I think what I'm going to do is I'm going to bring this down a bit more. Let's move it at 10 millimeters. Move it down 10 millimeters. Another 10. I'm going to bring it down a ways. Just making sure the nuts are all the way in there. And then I'm going to measure it and see how I'm going to check the distance between here and here and here and here. And I'm going to make sure it's the same on both sides because I don't think I've done that yet. And I want to make sure that they're level with the bed as much as possible. Otherwise, when we go to adjust the bed, it might be a waste of time if these aren't level. I'll go get my digital caliper. So I'm just going to 0 that, and then I'm going to get the other side to 0. Okay, and I can see that it is actually off. It's by 1.26 millimeters. So what I'm going to do is I'm going to click the motors off button right over here, and that'll allow me to manually adjust these by turning the rods. So I'm going to work on this side over here, and I'm going to try to get it to 0. And now when you manually turn these two, you have to be a little careful, because when you turn this, the stepper motor will actually act as like an alternator, and it'll pass energy over to the other motors since they're connected in parallel. So you have to turn it real slowly. Otherwise, if you try to adjust this manually and you're not looking over here, it'll actually start turning that motor too. Okay, so it needs to go up. Almost there. It's at negative 0.35. Negative 0.7. Okay. Let me just double check this side again, make sure it didn't move. Okay. Now, I have them to about 0.01 millimeters of each other. I'm not going to fuss with it and get it perfect. I'm sure, you know, the angle at which I'm holding the digital caliper could possibly be off anyway. So, and it doesn't need to be perfect either. And even if you didn't have a digital caliper, if you just used a ruler or something like that and did your best to get them level, it's going to be okay, because, I mean, it's better the more level it is, but you will still be able to get usable parts just fine. Now, if you're a perfectionist and you want to get it perfect, then you'll have better parts. All right. So now let's go ahead and move this down some more. The next thing we need to do is get this to a point between here and the top of the glass, to where it's a good position for printing. And then we'll move this around and we'll get it to the same position in all the corners, and then we'll set the end stop switch. Well, I mean, we'll set the end stop switch after we do the first test, and then we'll do the 4 corners. Okay, let's move it down some more. I don't know if you can you see that I'm clicking the 10 millimeter Z, negative Z? Getting there, you can probably see the reflection. Once it starts to get closer, I'll stop doing the 10 millimeter and I'll move down to 1 millimeter. You can also see that it's about to hit the end stop switch over here too. And it just did. It just hit the end stop. So you can see then the end stop switch isn't low enough because the nozzle is still too high. So I'm just going to adjust that. I'm sorry, let me move that over a little closer. So what I did is I pulled this down so that I could so I could get the Allen wrench in there. And so I could turn this bolt head down to move this down. Okay, let me move move this camera back out a little bit. And then I'm going to move the Z-axis down 1 millimeter at a time now. And here, let me actually get the camera even into a position where you can see the nozzle a little better. Okay, it's hitting the end stop switch again. So I'm going to adjust that down some more. Okay. Okay, I'm going to move the end stop switch down just a little bit more. And I'm going to, now that I'm really close, let me try to move the camera a little bit more. Okay, can you see how close that is? It's really, really close, but it needs to be a little bit closer. So I'm going to move the Z-axis up 1 millimeter, and then I'm going to bring it down in 0.1 millimeters at a time. Oops. Bring it down one more point. Okay, that looks perfect. It's just like a sliver. Oops. Sorry about that. It's just a sliver there, right between the glass and the nozzle. Wait, let me try bringing it down one more. That's actually perfect. It's hitting the end stop switch. And here, let me see. It's hard for me to get the camera in a position where you can see this. It's really easy for me to eyeball it. But there's just a sliver right between the tip of the nozzle and the glass. It's exactly where we want it, and it's hitting the end stop switch, so that's perfect. All right, so now I'm going to move this back up. All right, so now, but the situation now is that it's perfect in the center of the bed, but we need it to be good on all of the corners. So I'm going to carefully move the Y axis to the back, and I'm going to watch. I'm going to get my eye down to the plane of the glass, and I'm going to watch it and make sure that the glass doesn't start, or that the nozzle doesn't start scraping into the glass. Okay. Just had to make a couple of adjustments there. All right, looks like the front needs to come up just a little bit. So I'm just going to move it up a little bit. Okay. It looks pretty good. I think I moved it up just a little too much. So I'm going to put it back down. Okay. And now, again, I'm going to carefully move the x-axis to the right while I watch the tip and make sure it doesn't start digging into the glass. Okay, this corner needs to come down just a little bit. Okay, that looks good. And I'm essentially just eyeballing it to make sure that I have a sliver of light between the nozzle and the glass by getting down and looking down the plane of the glass. Okay, now I'm going to carefully move it over to the left and do the same thing. And in this corner, it looks like it needs to come up just a little bit. Okay, now I'm going to check the back corner. This corner looks like it needs to come up just a little bit. Okay, and then check the last corner here. And this corner looks like it needs to come down. And now I've seen some advice on this before where you should start with one corner and then just calibrate the other three corners, otherwise you're going to be chasing your tail. But that's looking pretty good to me. Okay, so that's all you really need to do. And I checked all the corners and they all look great. Alrighty. I had, when I first started out, I had the printer too close to the wall. And what was happening is the wires for the heat bed were pressed up against the wall, and it was pushing the heat bed a little forward. So I had to pull the whole printer away from the wall a little bit. So be careful about it. If you might notice the same thing if you have your printer too close to a wall or something like that. But okay, this is great. So now all four corners are calibrated. We got the end stop switch adjusted to a good height, and so that is fantastic. Now let's go ahead and move this back up. Let's move the z-axis up about maybe 20 millimeters. And let's go ahead and preheat the hot end. Now I have it set to 150 Celsius here, and I'll be using PLA. By the way, I do recommend that you start with PLA because it's a lot easier to use at first, and then once you become more experienced, you can try ABS. So go ahead and set that. It'll take a little bit for it to heat up. At the same time, if you'd like, you can go ahead and test out the heat bed by setting that to 50 Celsius. And you can watch, you can see right here that the heater, or the hot end, is increasing in temperature. It's at 6371 Celsius now. And I've also set the heat bed, and the bed is now at 26 Celsius, so the heat bed is definitely rising. I'm just going to kind of touch it a little bit to see if it's getting warm at all. But I can see that it is working, so I'm just going to go ahead and shut off the heat bed. It's at 30°C now. I just wanted to make sure that it was working. There's no reason to heat it up. What we're going to do is we're just going to test out the extruder and make sure that it can extrude. So let's get it up to 185 Celsius. Okay, it's at 182, 188. Okay, it's at temperature now. So, 195. Might need to make an adjustment to the firmware. It seemed to rise really fast. That's okay, it should be fine. So I'm going to go ahead and test out 5 millimeters of extrusion. So I'm just going to click the extrude button. And the extruder is functioning, and it is functioning in the proper direction. Let me go ahead and try another 5 millimeters. Okay, and I can feel that the filament is getting pulled down into the extruder, so that's good. Probably needs to extrude a little bit before it can build up enough pressure to extrude properly, but you can see the filament extruding here. There we go. There we go. Now it's starting to look good. Okay, now it's coming out nice. All right, I'll go ahead and clean that off and set the hot end to 0 by clicking the off button. So the extruder is working perfectly. That's great. All right, now all we have left to do is to check the X and Y axes and make sure that that they're moving in the right directions. So let's check the X-axis first. I'm going to try to move it to the right 1 millimeter. Okay, and it seems to be going in the opposite direction. Let me check something here real quick. I might have done that intentionally. Yes, okay. That is correct. That's right, I remember. Now usually I set up my RepRaps to where I have the end stop switch for the X-axis on this side of the printer and not this side, but I'm doing something new with this, with the i3s. I thought it would be nice to have the Y-axis end stop switch in the front. Having this here would allow you to home the Y-axis when you're done with a print job, and it'll actually bring your part to the front, which would be nice because then you could just pull it off right there at the front of the RepRap. So that's why when I'm asking the X-axis to move to the right, it's actually moving to the left. It's not backwards because it's in relationship to the Y-axis. So for example, if I tell the Y-axis to move forward, it should actually go backwards. Yes, perfect. That's exactly what I want. And then so if I tell the Y-axis to go home, it should come all the way to the front. Perfect. And if I tell the X-axis to come home, it should come all the way to the right. Perfect. Exactly what I wanted. And if I tell the Z-axis to come home, it should come all the way down. All right, everything's looking good. We're ready to go ahead and print this cube now. But first, real quick, I just wanted to point out that now printing on glass works great. And if you get any kind of dust or oil or like fingerprints or anything on the glass, it may cause adhesion issues. And one way to combat that is actually with Aquanet hairspray. And I use this stuff and it works fantastic. This is the unscented kind. So I just spray a little bit on the glass. And you really only have to spray like a little bit every 50 to 100 parts or so. And it'll just keep working over and over again. So now that we've got everything calibrated, we've got the filament loaded, let's go ahead and click the print button right here. Looks like the print center is off just a little bit. Probably about maybe 7.5 millimeters on the x-axis and maybe 10 millimeters on the y-axis. So go ahead and make a change to that real quick. This looks like it's printing pretty well so far. Let's go to slice 3R and see if See if I can make that those changes to this print center. Your print center might be slightly different, but I'm just going to try to show you how to change it real quick. So these values are from the end stop switch. So for example, I noticed the Y was a little too close to the end stop switch, so I'm going to move it away about maybe 110 instead of where it was. And the X was only off by about, I don't know, maybe 5. Let me put it at 95. Save that for next time. You could adjust, you can continue to tweak that until you get it just right. You can actually, you could measure it too with a ruler and get it just right. This is looking pretty good. Looks like it could be tweaked a little bit. Looks like it might be a little bit too hot. Could try decreasing the hot end temperature. Notice how there's some little blobs there in the corners. What's interesting is when I look at this in person, it looks better than it does on the camera. I'm not sure why that is. But there are a couple little blobs there on the right corner. And I think that might either be because it's not retracting enough, or it could be that the temperature is too hot. I think I would try decreasing the temperature first and see if that helps. Maybe just by 2 degrees Celsius. And every filament is going to print at a slightly different temperature too. This is the NatureWorks 43D PLA, which is a great material. It's really the best material to practice with when you're new to the hobby. I remember when I very first started printing with a RepRap, I tried printing with some pretty low quality plastic, and it was very frustrating. It would clog my hot end and I would have to clean it out, and I thought I was doing something wrong, and it was just really, really frustrating to try to figure out how to print with one of these RepRaps with filament that just wasn't behaving properly. Now I know for sure though that after a while, once you get used to how the printer operates, you could really print any material on the planet. But at first, you know, when you're first learning how to do this stuff, it's a lot easier to start with something that's more reliable, like the NatureWorks 4043D PLA. Prints really, really well. So this is looking really good. Like I said, there are a couple blobs in the corners, but maybe decreasing the temperature will help that. It does look like it's filling at about 70% density, like I had set in the Slice 3R program, and it's printing really, really nice right now. I'm really impressed. So I guess that wraps things up. I don't think that there's really much else we can go over. I do have some other videos on my YouTube channel that you could probably watch that might give you some tips, maybe some troubleshooting tips or things like that. And I know a lot of other people have YouTube videos too, maybe with calibration tips or maybe tips for improving print quality and that sort of thing. But as this printer sits right now, it's capable of printing usable, functional parts. So I'm pretty excited. I hope that your experience was just like mine here with this printer. I hope your cube is looking at least as good as this one. And you know, if you have any questions for us at Northwest RepRap, you can send me an email, or you can go to our website. My email address is Aaron, AARON, at northwestreprap.com or nwreprap.com. And you can also just go to our website. We have a contact form on there. It's at nwreprap.com. So If you have a question about print quality or anything like that, it might be helpful to send a photo of what it is you're trying to eliminate. And if there's some sort of failure that you're seeing, it might also be helpful if you could include a video. A few people have done that in the past, and it makes it really easy to try to identify the problem. Sometimes, especially with RepRaps and 3D printers, there's lots of terminology out there, and it can sometimes be difficult to try to explain exactly what's happening. So sometimes photos and videos just help tremendously in trying to help troubleshoot problems. But anyway, I hope you've had fun building your RepRap Prusa i3, and I hope that the video was helpful and accurate. And if you have any questions at all, please contact me. And enjoy. Have a good time. Thanks for watching. Bye.